Alright, welcome to this tutorial. Today our lesson is going to be based on dimensions and dimensional analysis. So we're going to talk about the dimensions of what? Physical quantities. Physical physical quantities. Right. So I'm saying that the dimensions refers to the physical nature of a quantity and expresses how it depends on the fundamental quantities such as mass, length, and what? Time. So we talk about physical quantities. Basically, these are what? Quantities that can be measured. Something like the mass, the length, time, temperature. So these are all quantities that can be measured, and they are referred to as what? Uh, Physical quantities. Now, what then is a dimensional analysis? So dimensional analysis is the study and the use of these dimensions to understand physical relationship, verify equations, and derive formulas. So you can see that dimensional analysis here that we are talking about have three parts. So it helps us to do what? Understand physical relationship, verify equations, and derive formulas. Each physical quantity can be represented in terms of a combination of base quantities using appropriate powers. So we can use the base quantities like the mass, the length, the time to do what? To represent what? These quantities, right? Yes. Now, let's look at the dimensional formula and dimensional equations. So the dimensional formula of a physical quantity is the expression that shows how and which of these quantities are involved in its measurement, and it is expressed using the symbols. We have mass, capital M, as a representation of what? Mass. We have capital L as that of the length, then capital T as what? The time. We have I as electric current, and so on and so forth. So these are all things that we can use to represent what? The the dimensions of what? Uh, a physical quantity. All right. Now, looking at the dimensions of quantities. So let's start with now. Normally, when we want to find the dimension of a quantity, say velocity, what we do is we base on three fundamental quantities. Fundamental quantities, and these are the mass. That's one. Two, we have the time. Three, we have the length. So we use these three to determine the dimensions of any physical quantity. All right. So let's say we want to, what is the dimension of this? Now, basically, we use this to represent the dimension of a physical quantity, right? So when I write this mass, this means that the dimension of what? Mass. If I write this, this means that the dimension of what? Time. Also, if I write this, sorry, if I write this, this is the same as the time that I talked about. If I write this, this means that the dimension of what? The length. All right. Basing on this, let's go back to this point. Now, mass, dimension of mass is given as what? Capital M. Dimension of time is given as what? Capital T. And I have the dimension of what? Length given as what? Capital L. Now, in this case, as I said earlier, we use these three to find the dimensions of these quantities. Let's say we want to find the dimension of velocity. And velocity basically, velocity is given a velocity is equal to what? Displacement divided by time. So the rate of change of what? Displacement is referred to as what? Time, velocity. All right. It's called what? Velocity. Now, what will be the dimension of velocity? This is going to be equal to the dimension of displacement divided by the dimension of time. Yes. Now, what is this displacement that we are talking about? Basically, this displacement here is talking about length, distance. So it means that from here, we are going to use capital L to represent what? Our displacement. So L divided by time from the basis, from the fundamentals, we have capital T. And we know that this can also be written as what? LT exponent negative 1. So this is an inverse here, right? So it means that the dimension of velocity is capital LT exponent negative 1. This is the dimension of what? Velocity. Now, what do you think would be the dimension of so let's try the second one, acceleration. Acceleration. Now, so the dimension of acceleration. Now, acceleration is the rate of change of what? Velocity. It means that it is velocity divided by what? Time. So the dimension of acceleration will be equal to the dimension of velocity divided by the dimension of what? Time. What is the dimension of velocity? Now, we did that from the first part. Then we realize that the dimension of velocity is what? LT negative what? 1. So we have LT negative 1 divided by the dimension of time is what? Capital T. Now we have this as LT negative 1, T negative 1, laws of indices, multiply with the same base. We add, right? So this is going to give us LT negative 2 as the dimension of what? Acceleration. Good. Now let's try another example. Let's try another example. Third one. What about the dimension of force? Now we know that force is given by what? Mass times acceleration due to gravity. So so this is mass multiplied by the acceleration. So what then is the dimension of force? Is equal to the dimension of mass times the dimension of what? Acceleration. Acceleration. And this is going to give us what's the dimension of mass from the top here, which is capital M. So we have it here, capital M. Then it means that from here we have capital M times the acceleration, the dimension of acceleration, which is given as what? LT negative 2. So this is going to give us MLT negative 2. This happens to be the dimension of what? Force. All right. So that is that. So it means that for you to be able to find the dimension of a physical quantity, you consider three things: the length, the mass, and time. Now, after knowing this, you have to know the definition for that particular what? Physical quantity. Just like we did, force is given as what? The mass times acceleration. The same thing. We are going for acceleration, velocity on time. So if you know all this, you'll be able to easily deduce what? The dimension of any physical quantity given. All right. Thank you for watching.